We're told that the diagram above represents the curve y equals x squared plus 5 and the line 2x plus y equals 8. So obviously this is a curve, which will be the one that, let's get it right, yeah, so this will be the y equals x squared plus 5, and this straight line will have the equation 2x plus y equal 8. So we know the curve is quadratic. The highest power there is a 2. Now let's approach the question. It says to determine the coordinates of point A and B. So point A and B will be the point of intersection of both equations, right? So what we want to do is to solve them simultaneously and to find the coordinates of A and B. So let's start with part A, to find the coordinates of A and B. So we know that y is equal to x squared plus 5. That's for the quadratic equation. For the linear equation, it's 2x plus y equal 8. And what we want to do is to make y the subject. What's one way of doing it? Since we have y equals x squared plus 5, we could also make y the subject for this linear equation. And so we'll have y equals, subtract the 2x from both sides. That will give us the negative 2x on the right hand side. We put back the plus 8, the positive 8. So it's just as if we transpose the 2x to negative 2x on the other side. Now that we have both equations written in terms of written as y as a subject in terms of x, we could equate both equations given that they're both equal to y. Okay, so let's do that. So I'm gonna put this equation here, y equals x squared plus 5. I'm gonna write the expression part of it, which is x squared plus 5. Since that is y, I'm gonna put this should be a positive 8, equal to negative 2x plus 8. Can you see the reason for me doing this? Well, this here is y, and this here is also y. This is for the quadratic, and this is for the linear. So equate both of them. And then I'm going to make the equation equal to 0, given that the highest power on x is 2, so it's quadratic, so we solve by setting the equation equal to 0. So I'm going to add 2x to both sides. In other words, I want to remove this minus 2x, and it should be plus 2x on this side. Oh, wait a second. I want to remove this positive 8, so I've subtract 8 from both sides. Alright, put back the plus 5, that's equal to 0. And this will give us x squared plus 2x minus 3 equals 0. Now I'm going to factorize this, and we use the shorter method, or at least what I call the shorter method. It's a trial and error method. X times x will give us x squared. I want to get negative 3, so now I'm going to use 3 and 1 to get 3 ones 3. And since I want negative at the end, 1 should be plus, 1 should be minus in terms of the two factors of 3. So I'm going to make the 3 positive and the 1 the negative. Why is that? So when I do this, I get positive 3x. When I do that, I get negative 1x. When I simplify this, I get the middle term, positive 2x. Alright, now, given that these two quantities multiply to give us 0, either this one is equal to 0 or this one is equal to 0. So either x plus 3 is equal to 0, or x minus 1 equals 0. Now if x plus 3 is 0, I can transpose the plus 3 as minus 3. So x is equal to negative 3. Or we can say we subtract 3 from both sides. Now x minus 1 is 0, so x got to be 1, because 1 minus 1 is 0. Or I can say I add 1 to both sides, making x equal 1. You can also check with this one, negative 3 plus 3 give us 0. So these are two values of x, right? So that means one value of x will be positive 1, and the other value of x will be a negative 3. Alright, now that we get that, I'm going to substitute these values of x into one of the equation, either this one or this one. So when x equals negative 3, let's use the linear equation, this one. I think it's much easier. Now we would have already transposed this, making y the subject, right? So I can use this one, which really is this equation. When x equals negative 3, y is equal to the negative of 2 times the x value, which is negative 3, plus 8. I'm using this equation here. So I'm in place of x here, I'm putting negative 3, since that's the value of x, and that will give me the value of y. So y is equal to 6 plus 8, which is 14. So when x is negative 3, y is 14. So that's a point, right? That's point A, obviously, because x is negative 3. So when x is negative 3, the y value is 14, right? Okay, so we have that. And so in other words, from here to here, all right, for the distance from there to there is 14 units upwards. This is the origin, right? Going right up, that's going to be 14 units up. So from here to here, that's 14 units. And let's look at B now. So when we have the x coordinate of B, which is 1, so when x is equal to 1, let's use the same equation. Y equals negative 2x plus 8. We're going to put 1 where x is. So y be equal to 2 times the x value of 1 plus 8. And we're going to get y equals negative 2 plus 8. Y is equal to 6. So the point there is when x is 1, y is 6. Alright, so when x is 1, going across here, the y value is 6. Alright, so that is clear. The point here is 1, 6. Just as the point here is negative 3, 14. For point A, that is. Alright, so point A is negative 3, 14. Point B is 1, 6. Alright, now what we should recognize is that, okay, so we got our 3 marks, right? What we need to do is look at the area underneath, the area of the shaded region. How are we going to find the area of the shaded region here, right? Talking about this region. We're going to find that area. Well, one thing we could do, look and see what we have here. So we have, we can recognize that we have, okay, let's look at a straight line, kind of. Alright, so, alright, it's not going to be perfect, but probably something close enough. Alright, what we can do is to think about what we have here. So this is point A, this is point B, and what we can do first, we can find this area here. Right, we can find this area here, the entire area here. What kind of shape is this, by the way? What kind of shape is that? Look at this straight line down here. Look at the straight line here. Oops, 1 second. Let's bring that back. Right. If we look at this straight line going down here, right? Let's use a color red. If we could look at this. Okay, it's like a little problem here. Now this shape here, right? That's basically a trapezium. because we have two sides that are parallel, and then we have some right angle here, right? But we have two sides that are parallel. All right, one pair of opposite side, or one pair of sides being parallel, and then we have the distance between the two parallel lines. We call that the height, right? So if we call this A, we call this B, and this we can call the height or the distance between A and B. Let's call that H. Then we can use the formula to find the area of the trapezium. This is a trapezium, and the formula is area of trapezium is equal to half the sum of the parallel sides times the height. Alright, so we can do that. So we can find the area of that trapezium, and then after we find the area of the trapezium, we can find the area. Let's look at that again. We can find the area. So I want to make sure that you understand in this. We can find the area, right, underneath this curve. Right, we can find the area underneath the curve. So let me just color that as well. We can find the area underneath this curve, right? So from the same 2 points, by the way. Let's draw the same straight lines again, but this time I'm going to find the area underneath the curve. Right, so imagine that we have this, and we're subtracting this portion out. What portion will remain? If we have this, and we're subtracting that portion, let me use a different color to highlight that. And we're subtracting this portion here. What portion will remain? It will be that same portion here, right? It will be this portion here that's remaining. All right, so what we want to do is to find the area underneath the trapezium, find the area of the trapezium, subtract the area under the curve, and what will remain is this yellow portion that we have here, this portion that is highlighted here in the original question. So let's go about finding the area of the trapezium, and then we find the area underneath the curve using integration. So the area of the trapezium now. Well, for the trapezium, we know this is -3, this is 1. We know this is 14, right? We know this is going to be what? This is how many units up? This is 6 here. So from 0 to 6, right? It's from here to here. That's 6 units upwards. From here to here, that's 14 units upwards. So we're looking at the y values to get the distance up. So that's 14 units, and from here to here is 6 units. So based on our trapezium, and from -3 to 1 is what? Well, if we subtract them, start from 1 minus -3, subtracting the negative is positive, that's 4 units. In other words, from -3 to 0, that's 3 units, and 3 plus the 1 more units, that's 4 units. Right? So for the trapezium, we have 14 units, 6 units, and the distance between both parallel sides being 4. So the area of trapezium is going to be equal to half the sum of the parallel sides, being 14 plus 6, times the height, or should I say the distance between the parallel sides, which is 4. Alright, typically we say height because we usually have the parallel sides being like this. These are usually 2 parallel sides, and the height may be like this. Right, so that's usually how the trapezium is written. So this would be the height, and this would be A, for instance, and that would be B. So you find the average of A and B, and then multiply by the height. Right, so the same concept, but this one is turned differently, right? But we want to recognize that the height there we're talking about is the short distance between A and B. So this would be my A, this would be my B, for instance. So half of 20 times 4, that's half of 20 is 10 times 4, that's 40. Let's give us 40 square units. So we found the area underneath the curve. In other words, this entire area here is 40 square units. But now we need to now remove this portion, the area underneath the curve. So it will leave us with this portion here, the area, the yellow portion. So the area on the curve, we can get that by integrating the curve itself. It's going to be this expression here, x squared plus 5 with respect to x. And so to integrate that, we're going to add 1 to the power of on x. That's going to be x to the third divided by 3. And remember, 5 is really 5 times x to the 0, right? Because x to the 0 is 1. So we're going to add 1 to that, which gives us 1 divided by 1. It's still going to be just 5x. Right? So this 5 becomes 5x. And we want to integrate this from, okay, since we're talking about area under the curve, we want to integrate it from 3 right up to 1. Alright, so that's going to be negative 3 to 1. Alright, so we're going to integrate between negative 3 and 1 because we want to get rid of this portion. We're integrating on, right? Integrating the curve there, this expression here means we're finding the area underneath the curve within these two boundaries. Alright, so this will give us what now? Let's see. Well, how we do this portion here? Well, we're going to substitute 1 into the expression where x is, and then we substitute negative 3 into it and subtract the 2 answers. So that's going to be x, let's go, so we're going to be 1 raised to the third power over 3 plus 5 times 1, and then we subtract, and then we're going to input negative 3 into this as well, right? So we're going to subtract both solutions. So we're going to have, if you want, you can put a bracket around this if you want to, right? And then we're going to subtract the other answer, which would be negative 3 raised to the third power over 3 plus, losing some space, plus 5 times negative 3. Alright, based on what we have there. Alright, so that would be that. And then let's see what answer we get. Now this is going to be 1/3 plus 5, right? 1 cube is 1, so that's 1 over 3 plus 5. So that's 5 1/3. Minus now 5 1/3 can be written as 3 5s 15 and 1 16 over 3 if you want to. Let's see what answer we'll get here. Cube of negative 3, that's negative 3 times negative 3 times negative 3, that's negative 27. And negative 27 divided by 3, that's negative 9. And 5 times negative 3, that's negative 15. Alright, so in the next step, you can say negative 9 minus 15, that's negative 24. Alright, I'm losing space, I'm going to just put the solution to that, would be negative 24. Now, when I subtract negative 24, that becomes what? Subtracting negative is positive. That's adding 24 in itself. Alright, so now when we add these, we're going to get 29 and 1/3. Right, we can add the whole numbers and then add a fractional part. So 29 and 1/3. So that's the area underneath the curve. Right, so this is the region here. Right, 29 and 1/3 square units. So the shaded region then, if the shaded region will be what? The area underneath the trapezium itself, this entire area here, which is, we got was 40. Right, and then we subtract the portion that we don't want, which is the area under the curve, which is 29 and 1/3. And that will give us 29, that will give us 32 over 3, right? 32 over 3. So that's going to be 32 over 3 square units. Alright, lacking space, but you can just put the square units there. And if you want to convert that, that's going to be 10 and 2/3. Alright, so that's another way you can write that, 10 and 2/3 square units. Hopefully that was helpful, but remember to put your square units.